Assalamu alaikum warahmatullah. So now let's talk about motion. So motion is the change of position of a body with respect to time. So there are different types of motion. We have linear motion, we have projectile motion, we have translational motion, random motion, and so on. But now the specific motion we'll be talking about now is the linear motion. That is motion on the flow like this, in a linear form. So now we are going to be talking about linear motion, and then we are going to be talking about the equations of linear motion. So there are three equations for linear motion, which are v is equals to u plus at, s is equal to ut plus a half at square, and then the third equation of motion is v square is equal to u square plus 2as, where all these parameters have their values, have their respective component. This v stands for velocity, final velocity, u stands for initial velocity, a stands for acceleration, t stands for time, s stands for distance. So these are the parameters present. So as you can see here, is narrated. V stands for final velocity, u stands for initial velocity, a stands for acceleration, t stands for time, and s stands for distance. But there are certain things we need to keep at the back of our mind. Whenever they say a body starts from rest, if they say a body starts from rest, that means initial velocity, which is u, is equal to 0. But if they say a body comes to rest, then v is equals to what? 0. If a body comes to rest, v is equal to 0. If a body starts from rest, u is equal to 0. So you have to take note of these two things. Whenever a body starts from rest, just know that u is equal to 0. And whenever a body comes to rest, just know that v is equal to 0. Now, let's see how we can apply this equation of motion. Many people know these equations of motion, but the problem is, how do they apply? They don't know when to use first equation, when to use second equation, and when to use third equation. So now, it depends on the question. Now look at it. They say Senator Gulu, on his way from old campus to new campus, increase his speed from 10 meters per second to 20 meters per second and maintain a constant acceleration of 2 meters per second square until he receives a message, that's a text message, from Senator Mekudi. At what time did Senator Gulu receive the text message? If he left old campus at 9:30 a.m. So now they want you to tell them when Senator Gulu received the text message. So people will say, am I a winch or the no. With physics you can know when he received it. So now let's check the parameters we are given. They say he increased his speed from 10 meters per second. That means his first speed, which is initial speed, was 10 meters per second. So u is equals to 10 meters per second. To 20 meters per second, that means his final speed was 20 meters per second, written down. Now, and accelerate uniformly, that is, the acceleration is 2 meters per second. So a is 2 meters per second. And then now you are asked to calculate what time, the time, that means we are looking for time. So this is time is unknown. So which equation has v, u, a, and t? So now checking the three equations of motion, this one has v, u, a, and t. This one has s, and in our question we don't have s, so we can't apply this. This one has s also, so in our question we are not given x, we are not asked to look for s, therefore we can't apply this formula. So this is the formula we are going to apply, because we are given v, we are given u, we are given a, and we are to look for t. So we are going to use the first equation of motion. So now from here we can say v is equals to u plus at. Our v, so take u from here to this side, or you say subtract u from both sides. You are going to have v minus u is equals to at. So divide both sides by a, you'll be left with t is equals to v minus u over a. You have made it subject of the formula. So now you can say t is equals to, what is our v, which is our final velocity, was 20. The final velocity of Senator Gulu was 20. and the initial velocity of Senator Gulu was 10, and he accelerated at 2 meters per second square. So 20 minus 10 will give us 10, now divided by what? 2. So 10 divided by 2 will give us what? 5. Of course, the unit of time is second. So now after 5, it was 5 seconds after he left Old Campus that he received the text message. So he left Old Campus, what time? 9:30 a.m. That means Senator Gulu will reach 5. If you add 5 minutes to 9:30, if you add 5 minutes to 9:30, it will be what? 9:35. So Senator Gulu received the text message 9:35 a.m. since it was 5 minutes after he left Old Campus, and he left Old Campus around 9:30. Therefore, he received a text message from Senator Mekudi at what? 9:35 a.m. Now, example 2 says President Osebaba accelerates uniformly from rest. What that word from rest shows that what? U is equals to 0. From rest meaning that what? U is equals to 0. From rest, U is equal to 0. It comes to rest, V is equal to 0. So since they say from rest, automatically U is 0. So now, at 20 meters per second square, so our acceleration is 20 meters per second square for 2 minutes. So our time is 2 minutes. So we need to convert it to second. So we say 60 seconds make 1 minute. Cool? So how many minutes will be in 2? So in 2 minutes. Seconds will be in 2 minutes. So it will be 2 times 60, which is 120 seconds. Now, from here now we can say, okay, and now they say we should calculate the distance covered. That means we are looking for S. So we are looking for S. So which formula has acceleration, time, and S? So look at this. Only these two equations has S, but this one does not have time, so we can't use it. So it must be the second equation of motion, because it has time, it has acceleration, and it has the distance. So if we come here now, our U, so remember S is equal to what? Ut plus a half at square as our second equation of motion, but U is 0. Since U is 0, so automatically this ut will approach 0, because 0 times t will give us 0. So what do we have remaining? We have S remaining is equal to 1 over 2 at square. So now from here we have 1 over 2 at square. So we can say S is equal to 1 over 2 multiplied by what is our acceleration? 20 meters per second square. Now multiply by, now what is our velocity? What is our time? Our time is 120 seconds. So 120 all squared, because the t is squared. So now from here we can say S is equal to this 2 here, 2 into 20 will give us 10 meters per second square, multiply by 120 square will give us 14,400. Now 14,400 multiplied by this 10 now will give us 144,000 meter. meter. So it shows that the distance covered by President Osebaba is what? 144,000 meter. So the question come again says President Osebaba accelerates uniformly from rest at 20 meters per second square for 2 minutes before coming to rest at Musa Mosque. So he came to rest at Musa. So when he came to Musa, it was what? It was after covering 144,000 meter. So President Osebaba reached Musa Mosque at what? 144,000 meter. So this is where we are going to stop. Once again, Assalamu alaikum wa rahmatullahi wa barakatuh.